Hello again. So today's lesson is about angles in a standard position, where we are going to take the concept of trigonometry and extend it. And to do that, we need to define few terminologies. First one is a standard position angles. So let's suppose that you have a Cartesian coordinate xy, and you have this coordinate p xy is on the line, and this circle has a radius of r, and the reason I have drawn a circle, I'm trying to show the path of that point P as it's moving around the Cartesian coordinate. Okay, so the radius is r. So a couple of things. Number one is that in order to create an angle, so the angle that we're going to look at is going to be this angle. I'm going to call that theta. That angle has to be created by two arms. One is called the initial arms, and initial arms for the purpose of this section is always the x-axis. Okay, x-axis is always the initial arm, and the terminal arm is basically the line that goes from the origin, and the origin is 0, 0. I didn't put it in there, but that's already there, to the point P. And that between the two, the angle theta is being created, and theta is now being said that this is the standard position angle. Now, there are a couple of things that we need to know. First of all, direction does matter. The standard position angle theta, couple of things. Theta is positive, that is counterclockwise, rotation, move, whatever. And if theta goes negative, or it is clockwise rotation, the angle of a standard position is negative. So be aware of that. That's very crucial. It does make a difference. Okay, so for simplicity's sake, let's look at another kind of a diagram here. I took the circle out. So let's suppose that the point has been moved, the point P has been moved to the new position xy here. So I can draw the counterclockwise standard position angle. That's my theta here. That's positive value, and that arrow shows that's going counterclockwise. Or I can have the standard position angle coming this way, and that theta is negative. Okay, so you could actually express the standard position angle as a positive value or the negative value. Another important thing is that can theta be any value? So as you go through the rotation, a full rotation is a circle, so a full rotation of angle, that would be 360 degrees. But is that it? Well, no. A standard position angle actually can go around the circle, around the origin, as many times. The rotation can be infinitely many. So therefore, there is no upper limit or lower limit for the standard position angle. All right, so it could be 2000 degrees, 4000 degrees, or subtraction or negative, the clockwise rotation. So no limit, no lower limit nor upper limit for standard position angles. The next terminology that we're going to talk about is called coterminal angles, and that's actually quite simple. If you look at the original, let's look at this example right here, right? So we have a terminal arm, which is the point P is on it. That's the black line, right? Notice that both of these angles, they're both considered to be a standard position angle, and they both end up landing on the terminal arm. Okay, that's where the angle terminates. That means this stops. Well, both of them basically land on the same terminal arm, and because of that, we call that coterminal angles. Okay, look at a specific example. Let's suppose we have a standard position angle of 30, and we want to come up with we're going to come up with a couple of coterminal angles, one positive, one negative. And by the way, coterminal angles could be positive and could be negative. You have to locate the terminal arm. So we have the terminal arm, so there is right here, that's the terminal arm, that's TA. I'm going to call that TA. All right, the very first thing we do is that, okay, I want to hit the terminal arm. I'm going to use, let's say, positive coterminal. I'm going to start with on the initial arm. I'm going to go around, and I'm going to come back, and I'm going to hit it one time. So I'm going to do a full rotation from the initial arm, which is on the x-axis. Always you start from there, and then you hit the terminal arm and you stop. What is the measure of a new angle? Okay, the new angle, let's call that theta 2, is 360 degrees plus 30 degrees, because you did one full rotation. So the new, or the first positive coterminal angle is 390 degrees. All right, now let's look at a negative. So same terminal arm, this time we want to do negative. Well, I start with on the initial arm, but this time I have to move clockwise, and I do that until I hit the terminal arm and I stop. What is the measure of that? Well, first of all, the moment you go clockwise, you're starting with the negative value. Okay, so that means that if the total will be minus 360, so minus 360 degrees, because you're going to rotation negative, you have to subtract or add away, it's an interesting way to say it, the 30 degrees, the initial standard position angle. So now we have minus 330 degrees. That is the first negative coterminal angle to that. Now, is that the two? No, you keep adding the rotations to that, and you can come up with 4 billion different angles as well. So anything from this point on can work. You can actually say plus another or do a subtraction of negative 360 degrees, and then keep doing that however many times you want. I'm going to call it n, multiplying by n number of rotation, you get new angles. And this one, the first one, you can just add 360 degrees and multiply that by however many times you want to rotate, and they will get a new coterminal angles. Okay, so this goes on forever. The last one that is important, very important, is called the reference angle. And here's a definition, that if you have any angle that is drawn in a standard position, let's suppose we have this angle right here, call it theta right there, right? And the reference angle is the angle between the terminal arm, so this is your terminal arm right there, this is the terminal arm, TA, and the x-axis. And we have the x-axis, which is right there. That's your x-axis, right? This is your x, this is your y. And the angle is the angle in between. Now, it says acute angle, and it is always acute angle. Okay, in this case, what we have is the angle lands in quadrant 1. So remember, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. You've learned that in previous grade. So that's what the Cartesian coordinate is divided by, 4 quadrants. All right, so what is another example? Well, what if we have angle that is here, and the standard position angle is that? Let's call that alpha. All right, according to the definition, we follow the definition, and so the angle between the terminal arm, so this is our terminal arm right here, that's our TA now, so this is the TA, and the x-axis, so that's your x-axis. It doesn't say positive or negative, it just says x-axis, and the new angle is the angle in between two. That is our new angle, and that would be the reference angle to angle alpha. So that is the reference angle. Okay, and in this case, the theta case, that is called the reference angle. Okay, let's look at a couple examples. We want to find the reference angle to each of these standard position angles. So the first thing first, we have to draw a quick sketch of the standard position angle. Now, when I say quick sketch, that means it doesn't have to be accurate. So 150 degrees is approximately around there. So this is the 150 degrees we're looking at. Now remember, it is a positive, so its standard position angle starts in the positive x-axis and then rotate counterclockwise. So here it is. What is the reference angle to 150 degrees? Well, the reference angle is the angle between the terminal arm and the x-axis, right there. So what is that angle? That angle is 30 degrees, because angles on a line, they have to add up to 180 degrees. We got 150, 30 is remaining. Simple as that. Now you go ahead and do the part B. Now make sure that when you do part B, your standard position angle is negative. That means it has to be clockwise. So when you start that, that's your x. So negative 250, we know that it's coming from here to here, going this way, from the fourth to the third, that's negative 180. And then once we hit the vertical line, that would be 270. So it's around there. That's where that is. So here is the rotation of minus 250 degrees. Great. What is the reference angle to that? Again, is the angle between the terminal arm and the x-axis. Now remember, terminal arm. So again, this is your terminal arm, TA, and the angle that you're looking at is right there. It has to be acute. What is that value? Well, let's look at it. If the entire thing is 250, but from here, from the main part, the bottom piece is 180 degrees, right? This piece right here is 180 degrees, right there. So what do we have to add to get 250? Well, in this case, will be 70 degrees. Now, one more thing, it's acute angle. Reference angle is always positive, it's never negative. Direction doesn't matter with the reference angle, and that's basically it.